So that brings us to our last talk of the day with Frankie G. Frankie, come on up. Frankie's here talking about, he works at Malwarebytes, where they've built this really cool tool, Shiba, doing all sorts of cool things in serverless ChatOps. Why don't you tell us all about it?
Cool, thanks. All right, hey guys, we're at the last presentation. I hope everybody's enjoying DevOpsDays, the first one in Tampa. So, hang on, it's pulling up a little bit. So, I don't have a slide for myself, but just a little bit about myself. My name's Frankie, and I'm a site reliability engineer at Malwarebytes. Before that, I graduated 2016 from University of South Florida through the computer science program. And far before that, I've been working on my own labs and tinkering with stuff. So just a little bit quick background about what I am. So let's get started. So we have some topics we're going to go over, and just a quick overview of what's going to be covered today in the talk. First, an introduction of talking about what serverless is and what exactly ChatOps is, for those people that haven't really heard of the terms or might not be familiar with what this is. And we can get a little bit further on into like traditional ChatOps and how we built Shiba to solve our issues with our traditional ChatOps. And we can wrap it up finally with any issues, all the issues we encountered in the past with actually implementing serverless with our ChatOps. All right, let's get started. So, what is serverless? I guess a quick question for everybody is, has anybody heard of serverless so far? It's been a pretty big buzzword. Awesome, see a lot of hands. Now another question, has everybody used serverless before? Those people that actually raised their hands? Awesome, so we got a good crowd going here. Serverless, pulled right from Wikipedia, paraphrased, is it's a cloud computing execution model. It's a lot of the responsibilities is put on the cloud provider rather than the actual engineers, so it saves us a lot of like infrastructure management. Resource allocation, for example, is huge. We don't have to guess our sizes as much as we do with, for example, VMs. Especially when you're working in cloud, it gets a little bit tricky to right size and everything, and a little bit expensive to do so as well. OS level security, we don't have to worry about that. That's very transparent. And next is elasticity, which kind of falls under scaling. A lot of serverless technologies out there handle scaling for you. So we don't have to build our own scaling solutions or write our own custom stuff out there. So that's kind of what the traits of serverless is. Another trait of serverless is how they do their cost models. You pay for what you use rather than what you're trying to provision. Take, for example, on AWS, for example. I'm going to use AWS a lot because we work a lot with AWS. So for AWS to spin up an EC2 instance, which is a VM, you specify the size, you get it, you pay for what you pay for the hours. But for serverless, you only pay for the computing time that you use. And after that, yeah. So some good examples of some serverless technologies that people probably worked with before. If you're familiar with AWS, Azure, or GCP, Lambdas is probably the most popular ones out there. That's everybody's been using, right? S3 is actually a serverless technology. If a lot of people kind of skip over that, as they view it kind of as just a storage. And DynamoDB obviously is a serverless technology for a NoSQL approach. And yeah, I'm not going to probably go over the other cloud providers at the moment. But anyways. Same question for ChatOps. Has everybody heard of ChatOps before? Or awesome. And what about using it within your company? For example, if you have Slack or Discord or Teams, awesome. Just a quick question, if anybody wants to answer, like, do you guys use it for deployments, or do you use it for any other internal tools, or just kind of like a karma tracker thing? So it's kind of for alerting and monitoring as well? Awesome. So ChatOps itself, it involves the collaboration tool and puts it as part of the process, the pipeline. And it does common tasks that we usually do, and it's right there in our communication and collaboration tools. So it allows us to integrate our collaboration along with our processes. So for example, ChatOps, some tools that, I guess, functionality that ChatOps would be doing would be code deployments, which is a very, very big one for a lot of people. Some people like to list on-call schedules or see who's the point of contact for a particular service. And ChatOps is actually a great thing for that, since we're already in the collaboration software, and we just check who's, for example, an owner of a certain application is right there. You can go right in there to start messaging if needed. And another way we use it is actually just to create firefighting tickets. So teams can be out there to create firefighting tickets directly to SRE. We'll get notified. Everybody's probably heard of some famous tools out there for ChatOps. Hubot is one of the most popular ones developed by GitHub. I've seen a lot of people use it. We actually used it also at Malwarebytes prior to switching over to our serverless models. And we'll talk about a little bit about why we made that decision a little bit later on. And obviously, there's some common collaboration tools out there like Slack, Microsoft Teams, Discord. And they all have their nice features. They're all a little bit different from each other, but they accomplish some of the same goals. Moving on. So just to let you guys know, something that we observed at Malwarebytes as engineers, SREs actually, to manage the ChatOps. It was actually managed by the SRE team just because it was part of internal tooling and processes. So we self-hosted on its underlying infrastructure. In our case, we specifically used containers, ECS for AWS. So it had an underlying infrastructure of like EC2 instance, which we did have to pay for 24/7 because it's going to always be up. We can shut it down if we want during off hours, but our company is international, and there's people working around the clock. So it's going to be burning away a lot of resources. The authentication itself wasn't the best. We didn't really have it integrated directly with the chat. We kind of just made users and just assumed that they have the permission to do it. So it wasn't the best way to secure it. We just have to hope whoever's at the computer at that moment is who they are. And that's our own authentication we have. And anybody else out there that doesn't have the authorization to deploy something or to check some information, they were able to do that, just adding it in. Another issue we noticed is users always complain it's broken or it's not responding. And it's really difficult to capture because sometimes applications just die for some reason. And it gets a little bit hard to debug it, and because it doesn't recover as well. And the bot itself is always listening in the channels, which offers another security issue because it basically goes through and reads every single message that comes in every time you add the bot, right? And sometimes you have to create an API key for that, a read API key, and if that API key gets lost, anybody around there can be reading your stuff. So it's a little bit risky there too. And I think I covered some of the cons over here. It's expensive to host, obviously, because we have to have the underlying infrastructure to host application. But most ChatOps out there also integrate databases and some kind of storage out there. So people have to leverage both the application infrastructure as well as database. In our case, we had a Redis instance out there that handled our user management and deployments. Something I already covered, it's really largely underutilized for what we're paying for it and how much we size it, just because the limitation of how small we can make something and handle the scaling around it, which brings to the self-managed scaling. We have to manage our own scaling, put our own auto-scaling rules behind it, and hope that's what we need. And as the user base grows, we might need to adjust those targets here and there. And last, not last yet, but user management, right? It's really taxing to write your own logic for user management if it's not built out of the box. And sometimes you might end up in situations where users are blocked because they're not able to deploy based on security. And user management, my bad. And lastly, security. Due to having the always listening bot, we have the API keys, which ended up with security issues, which discussed before. But on top of that, Foodbot itself had some other issues when it comes to communicating with applications. So let's go to the next one. So to solve all the issues we had with Foodbot, which is something we built inside Malwarebytes, we switched over to Shiba, and we sat down, we engineered it with the engineering team, just a quick whiteboard talk about it. And I went home over the weekend, and I took the design, what we had, what we drew up, and I wrote it probably in about 20 hours, and with some help of alcohol, obviously. And it really helped. I think that shortened down the time from 40 hours down to 20 hours, so it was great. Had a fun time. I came back the next day during work, and my boss sitting right there. I'm like, hey, dude, check out this thing I just built. It's something we talked about, but it did some basic stuff. It kicked off deploys and had user management in there. And he was like, you know what, I like it, let's ship it. So a few weeks later, we put it in production, and we deprecated our previous bot. So just to give you an example of, just to kind of highlight the amount of effort it took to develop this kind of, just one developer, one engineer. It took me 20 hours to just develop this whole structure, infrastructure, code, everything, all the way down to security and part of it. So currently, Shiba is part of Malwarebytes' deployment processes. All developers use it to deploy their code out. We don't actually touch deployments as much, because whenever the developer commits their code in, or they want to deploy off a certain feature branch that they're working on, it's all possible through Shiba, and Shiba just does it for them, and it works out really well. And give you a little bit of estimate how many deployments we do through Shiba. We do probably 1,800 a month, which is quite a lot. It's pretty agile, in my opinion. Agile. So moving forward, this might get a little bit more technical and a little bit geeky, but if you guys can bear with it, it's great. This is the architecture of Shiba and what it looks like. It's very straightforward. If you look at it, you start seeing a little bit of AWS structure in it. A lot of AWS involved, actually. And we are using Jenkins as well. So let's go over through what this diagram looks like. Starting from the very beginning, we have the Slack users interfacing with Slack to do a slash command. Just like, add it in, Shiba is a slash command. It's integration rather than actually a bot on their listening. So we don't really call Shiba a bot. We call it an application or an integration rather than a bot. Once the user puts in their command through to Slack, Slack takes the context and they send it over to the API gateway, which is the serverless, serverless REST, basically, what AWS uses. And we have Shiba's API gateway sitting there listening, which forwards the request over down to a Lambda function. The Lambda takes the request, kind of authenticates it through DynamoDB, which you see number 3. And it makes sure that the user has the permissions to do it, and it takes out any other information that we might need for deployments, like job and what kind of parameters they take. And just to let you guys know, we actually just have one table out there for literally everything. We call it Shiba things. So we didn't need to leverage multiple databases or doing cross, anything complicated. Just have an index on there. Everything was worked out just fine. We don't have any scaling issues or performance issues. Number 4, we can talk about a little bit later on, but Shiba does interface with a queue system just to kind of solve one of the challenges we did have, and we can talk about that challenge later on. And 5 is our kind of part of our monitoring. Shiba logs all their Lambda itself logs directly at CloudWatch logs. So we leverage that for logging. If we ever have an issue, we go check CloudWatch logs, or there's another solution I'll talk about a little bit later on. And we use CloudWatch events as well to kind of monitor Shiba, make sure it's not erroring out, it's not having any issues. And number 6 is kind of some examples of what Shiba interfaces with. If you probably read it here. The most popular one for us is Jenkins, because everybody likes their deployments without going through a manual process. Well, the manual process is just them typing, but you know. Anyways, we interface with Jira, and everybody's probably familiar with Jira as one of those ticket tracking systems. And VictorOps is what we use for on-call, and they wake me up a lot. So, and AWS, Shiba interfaces with AWS for features, for example, like checking an IP address of an EC2 instance, and we can just grab that out. We can come back to this. If you guys have any questions about this design, you can come talk to me a little bit afterwards, and I'm happy to answer any questions. So let's kind of move forward with what we got. So this is the cost of Hubot that we hosted. It is a little bit inflated due to the fact that we didn't revisit it many times to right-size it, but we did have to run it in multiple environments due to security reasons, because we have multiple AWS accounts, and Hubot itself didn't handle cross-account very well. So just take a good idea is it's hosted on EC2. This is the cost of all the EC2 hosts, underlying hosts for our containers for Hubot. And this doesn't actually include the database backend for Redis that's shared amongst other resources. So we're not even including that. So if you can see, $500 a month, it's not really expensive for a company per se, but it's pretty expensive for what it does. And we were kind of wondering if this was worth the money that we're paying for it. So moving on, we can go check out comparing to what we're paying for Shiba, which is cents, not cents, dollars, which is a 98% savings from what we were paying for Hubot before. And when we brought this cost savings up to just our boss, he was happy, really happy. So Shiba itself is entirely serverless. We don't have anything to manage. Nothing's out there running. We're paying by the hour for it. We pay per invocation. Basically, we pay per command that it gets called. Approximately 2 cents a day, which is super cheap for what it does, and everybody loves Shiba. And let's move forward. So one thing I'd like to add about Shiba is it's really extendable, very easy to extend for anybody on the SRE team or any other developers actually out there that wants to contribute to it. We have all the documents out there to kind of let people know how you add in a new function. And it's as simple as importing a new module. It's written in Python, by the way, but it's as simple as importing a new module, and the module just has to follow some guidelines for it to actually just pick up and work. So a lot of SREs and developers actually start contributing Shiba after our initial release, and it's expanded out to a lot of additional functionality compared to what we originally had of just deployments, right? So one example we have is creating Jira tickets out here. We have some, it basically helps us create a Jira ticket right there in our collaboration software, which is really helpful, especially when people are talking about an issue right there. Sometimes people get a little bit, lazy. I'm definitely not innocent with this. I'll say I'll create a ticket a little bit later on, and it usually doesn't, sometimes it doesn't get done. And I'm pretty sure a lot of people are guilty of this as well. So having it right there in our Slack collaboration, right when an issue gets, right when an issue pops up and discussions go on about it, users are actually able to create the ticket right there and then. There are other tools out there that does this functionality for Jira, especially Jira's native, Jira's own Slack integration, but it doesn't actually do exactly what you want to do. It's not as flexible as what we want it to be, and a lot of them have licensing costs, additional licensing costs in order to get it to be adopted. So Shiba itself it's built in-house, so we get to control all of the functionalities, what we want to do. For example, if we want to always add a component to the ticket, we can actually bootstrap that very well and very easily for just a particular SRE board. And the one on the right here is an example of how easy it is to just do a deployment. The command is literally just /shiba deploy, and it's my application that I tested out. And I deployed to dev just to let you guys know in case. Anyways, let's go on. So maintaining Shiba is much easier than maintaining a real dog, much easier. Just due to the fact that we don't have to manage any infrastructure, we don't have to manage any security updates, none of that. It's just living there. AWS handles all of that for us. Our deployments are actually pretty interesting for Shiba too, because we actually use Shiba to deploy itself. And the reason is why not? If Shiba just kicks off to Jenkins redeploys Shiba with the code, and it's done. And there's virtually no downtime besides something I'll talk about a little bit later on, just due to the fact that it's on Lambda and it's always up, and we don't need to worry about putting anything down, just scheduling maintenance windows for it. So we're very, very agile with it. We can deploy Shiba anytime we want without worries. Lower environment testing is one big thing that we had with Fubot, and that's actually why we had such a big cost, is we have replicated lower environments as well as multiple other environments. So it ended up being a little bit costly before, but with Shiba being a serverless technology, we don't have any underlying cost for replicating the environment because it all depends on per use case, right? We pay on invocation rather than having the Lambda out there. We might have to pay a few cents for the information stored in DynamoDB for storage reasons, but it's really negligent compared to what we have to do with the database itself. So another thing we do is we actually limit down the permissions in the lower testing environment. It's really easy to do so. Logging and monitoring we talked about already. We use CloudWatch logs and metrics for monitoring and logging. But additionally, on top of that, when we're to make debugging and testing Shiba easier through development, we have a debug channel created just for Shiba. It's called Shiba Logs, and we actually test our Shiba stuff live in Slack in that channel. Whenever we have an error, the stack trace actually gets put into the chat for us so we can check it out. When users are actually using Shiba and they come to us, hey, I just got a generic error from Shiba, we go to that channel actually because it's much easier than signing into AWS and going to CloudWatch logs and trying to figure out what it is. The log itself actually has a stack trace with the command and the user that actually ran the command. So it's really easy to track down our issues and what the stack trace was and then look back at the code base and compare. All in Slack. Security, Shiba has 3 layers of security. On AWS end, we leverage IAM to communicate with our SQS, DynamoDB, S3, all that good stuff. Security groups out there help kind of control what Shiba talks with. And it's mostly for the things that Shiba interfaces with rather than Shiba itself, because it's a Lambda. On the other end, we have other network-related security things such as NACLs, WAF, and route tables. Now on the Slack end, we have unique team ID that we actually authenticate against to make sure this is coming from Malwarebytes official Slack server and not some test server or some other rogue server the request is coming from. Otherwise, we might end up with people from another company or just another server deploying our application, which is not cool, right? On top of that, we actually leverage OAuth for it to actually communicate back with Slack. And user authentication, something else we use. We use the actual user ID that Slack gives you as their identifier in our DynamoDB table, which makes it very easy to just integrate with Slack. And just a little bit of information about our application and infrastructure code. We wrote it in Python 3, and infrastructure code is tracked with Terraform. And that's actually how we do our deployments too. So moving a little bit more forward, I think this is the last slide. So this is some challenges that we actually encountered while developing for serverless ChatOps. One of the biggest things we notice out there is Slack has a very strict 3-second timeout. As in, once you make that request out to wherever after you do the command, Slack hopes that you can respond back within 3 seconds. If not, then Slack gives the user a user time, there's a timeout for whatever your request was. So it's really hard to circumvent it. So we actually implemented the queue system that we talked about earlier. So we leverage SQS, and once we get the message, the context right directly from Slack, we queue that message directly into SQS, and we have Shiba recursively call it right afterwards. And while that's going on, we actually respond. Shiba actually responds back to Slack to acknowledge that, hey, we got your request. It's all good. And as Shiba consumes that message again, there's a callback URL that Slack graciously provides us to kind of help us get around this. And we just post back to that callback URL, and that callback URL has the context of who made the call and what channel they made it in, and it responds back to them as intended. And it really gets around our 3-second timeout and makes a lot of our longer running functions more feasible. For example, making 3 API calls to AWS might already go over those 3 seconds depending on what the situation is. So one of the things that's a little bit harder to get around is the cold start delay. As you all might have know if you worked with Lambda or serverless technologies. They have a cold start time. They're really fast, but they do have a cold start time that might impede the speed of how you're working. And you really have to develop around this and with the serverless in mind instead of how your people are usually comfortable developing. So before I get into the concept of pre-warming the Lambda, because that kind of mitigates our cold start delay, I kind of want to put the concept out there just for everybody. There isn't really a strong concept of pre-warming a Lambda due to the fact how Lambdas work. Once you can keep calling the Lambda over and over again with many requests, but it will keep reusing the warm one. It won't actually instantialize more Lambda implications to handle your request unless you have parallel calls, concurrent calls. And that also leads to another issue we'll talk about a little bit later on. But we have one thing out there. We call it the Shiba blanket. It keeps the Shiba Lambda warm, right? Get it? It's pretty cool. And it makes sure there's at least always one kind of warm Lambda out there to take the user's call. And there are situations, for example, right when we first deploy out Shiba, how AWS does it is they cycle out the Lambda. And once they get the new Lambda code out there, they actually don't instantialize it until someone actually calls it. So we hope for that the Shiba blanket will kick in before another user wants to make it their next deploy. Because once the user makes their deploy, it might time out due to the cold start. Now, the last one we have to worry about a little bit is account limits. Lambdas, if everybody's worked with Lambdas and heavily worked with Lambdas, has anybody ran into any concurrency issues that throttle is in AWS by show of hands, any chance? Cool, one guy, it's awesome. It's not really fun to deal with it. There's two types of throttles that goes on with Lambdas, or I'm talking solely on AWS, by the way. There's one that's increasable, as in AWS puts it out there to kind of protect your wallet, is you don't want so many Lambdas running. You can actually have that AWS increase that limit to whatever you wanted to increase it to. Now, there's a second one out there that's called the burst throttles, and that's something that you can't really get around, and that's per account per region. So in US East 1, for example, we have a total max of 3,000 burst concurrency. Well, what burst concurrency is how many new invocations of Lambdas that you spun up within a certain amount of time. And I think that time is like 5 minutes. And if it overcomes 3,000, every new invocation that you try and start out will start throttling. And that's not something you can get around. And this applies for your account, not just your individual Lambda, but for your account on that region. So for example, if you have other services out there that's heavily using Lambda, I would probably consider putting Shiba or any kind of serverless technologies away from the heavy Lambda accounts and region, because we do run into throttle count, and then everything's broken after that. It kind of backs up. It has a domino effect. But yeah, after that, I think that's all we got. So I guess I can open up for questions if anybody wants. Afterwards? Yeah, okay, cool. I'll open up for questions. Come find me afterwards. Ask any questions. So.